Hi, welcome back. This is part 2 of the FAT16 file system. So last night I left you with how to find the root directory. And rather than have to get my camera out, here's the display on YouTube. So using a few calculations, we found the root directory was at sector 472. So in case you're not familiar, I used Windows Calculator. If you haven't seen any of my previous videos, you get Windows Calculator, go standard view, scientific, that's a new one, graphing was new, and then programmer. And then there's a decimal number, put a decimal number in here, converts it to hexadecimal or binary. But hopefully today I'll give you the knowledge to work out hexadecimal numbers without the need of a calculator. Since we have the calculator here, you can see the number of sectors on an SD card, so FAT16 will only work up to 2 gigabytes. So if we have a look at these sectors, 384, 2048, 2048. That's the number of sectors, and as I explained the other night, there are 512 bytes per sector. So if we take that number of sectors multiplied by 512 equals, that's nearly 2 billion, or 2 gigabyte. That is the maximum size for an SD card using the FAT16 file system. So to find that root directory, we had to find the number relating to the start sector for FAT1, also known as a reserved, and it was found at hexadecimal E, and it's a one word, so that means it occupies E and F. So 14 and 15, then we get to hexadecimal 10. To give you a prime example of how little endian can catch you out, bytes per sector starts at hexadecimal B, and it's one word, so that occupies B and C. And then the next value is D, you can see there, so we want B and C. Bring up the HXD program. This is the brand new formatted card. So up there, B and C. B is nothing, C is 2. Well, there's not 2 bytes per sector. Remembering this is little endian, so C is the most significant number, followed by B. Windows Calculator, Programmer View, change it to hexadecimal. So C, put the number C in first, 2, then 00. We've got 200, decimal 512. So B and C, that's 512 bytes per sector. So that's, you've got to remember, all these numbers are little endian. The most significant comes last. So now you know how to work out bytes per sector. So moving away from the SD card data, let's move to the file data. Now on this SD card, it's a newly formatted card, and I've put just one picture, the Paris bitmap, and we'll have a look at it in a second. But so the offsets are similar to the SD card offsets, SD card data. So if we look at this, the file name starts at offset 0, so that sounds easy enough, doesn't it? Then since the file name is 8 bytes long, the next bit of data, which is the file extension, whether it's a JPEG, BMP for bitmap, PDF, TXT for text file, that starts at 8. Then you've got the file attributes, whether it's a read-only, file creation time milliseconds, don't know what that's about, creation time, the date, last access, extended address index, but the important parts are the first cluster of the file, which is at offset 1A, and the 4 bytes, which are the file size. Let's have a look. So from the boot sector, let's go to the root directory, which happens to be the same on this card, 472. There we are, a symbol clean root directory. There's my card name, and there's the Paris 1 bitmap. So it's starting at 0. If you look at the top here, there's 0. The file name can be 8 bytes long, so 1, 2, 3, 4, 5, 6, and you'll notice 7 and 8 are empty. Hexadecimal 20 is decimal 32, which means a space. If you've got microelectronica's tools, ASCII chart, space, decimal 32, hexadecimal 20. So if you don't use up all the 8 characters, the computer must put a space in there. But then the next important parts, like 8, 9 and 10, so A, 8, 9, 10, these are the file extensions, and in this case BMP for bitmap. So I've yet to figure out how do you get from there to there. Each entry in the file allocation table is 32 bytes, but my Paris bitmap is down here. I've yet to figure out, well, how do you know it's here and not here or here? If we look at my C file, scroll down to the bottom, since each entry is 32 bytes, that's divisible by 8. I'm using the function that converts any letter found to an uppercase. I'm looking for the letter T. If it finds a letter T, it converts it to a capital case or uppercase if it's not already an upper. So that's my T, and then if the next character is an X, it displays the name here. If it doesn't find the T, it moves the location on 8 bytes. So this is finding the first text file, this is finding the second, and then this is finding the bitmap. So I'm looking for a B and then an M. So once my program has found the bitmap, because it will, you then need to establish a few things like where is it on the disk, or maybe the date or time it was created. If we go back to this file table, let me show you how to calculate the last update date. So at 18 hexadecimal, back to HXD, so 18 hexadecimal. So this would be 0, this first line, and then same as this second line up here, this next line is 10. So 10, 11, 12, 13, 14, 15, 16, 17, 18. See, it lines up with the 8 at the top. So 18 and 18 is 2 bytes. 18 and 19. Put those into Windows calculator, hexadecimal, remember little endian, 53, 39. What's that? 21,305. That does not relate to a date. Let me show you how to work it out using hexadecimal and decoding it that way. Right, I've copied the root directory and put it into Windows Paint so we can work this out live. So Microchip instructions take this date and then the time, which is here, these 2 bytes. So they convert that into a 32-bit integer and break it down to give the date and then the time. But to make it easier, I'm just going to concentrate on the date. So remember they're little endian. So if we copy these numbers, write them underneath. Little endian, remember, so the back to front, 53, 39. And it made no sense on the calculator. Now, if you haven't seen my video on bytes and nibbles and hexadecimal, this will mean nothing to you. So I suggest you go and get genned up on hexadecimal. So 53, I'll show you an easy way of working it out. Concentrate. If you've seen my video, then you'll understand what I'm doing. To remind you, so 128, 64, 32, 16, 8, 4, 2, 1. These are the values, the decimal values of a byte, and they're important because we need them to work this date out. Obviously, if you've got an integer, as I've explained before, the next number up would be double this number, so 256. then double 256, 512, and it goes up and up and up. But we're just going to concentrate on this byte. Right, so we're converting from hexadecimal. Don't worry, it's all easy. Watch. So with the first digit here, 5. This 5 is the most significant nibble, so 4 bits, of this hexadecimal number. So 5, how do we make that in binary? Look at this table up here. Right, so to make 5 using these numbers in this box, how do we make 5? We want one of them, no 2's, and we want a 1. That's sort of lined up. So obviously there are 4 bits, so we need to put a 0 ahead of all of this. That should work. There's our 5 in binary. Then we've got a 3. So if I cut this, put that down there, we've got a 3. So to get a 3, we want one of those. We want one number 2 and one number 1. That gives us 3. Nothing in front, so 2 zeros. 0, 0. You might think this is long-winded, but it's also teaching you how to convert a hexadecimal number into a number. Cut that. This number here was a 3, something like that. So 5, 3, then a 3, 9. Oh, so that's handy then. So 3, copy, paste, 3, then we want a 9. So how do we get a 9? So 9, so that's an 8. We want a 1 number 8, no 4's, no 2's, and we want a 1. That's 9. Cut. 9. So that's our binary representation of hexadecimal 5339. Anyone can follow that. Even my granddaughter, who's 8 years old, I've been teaching her this. She's a wizard. Let's see if this ties up with what the Windows calculator says. Cancel, so hexadecimal 5339. There we go, hexadecimal 5339. So we've got 1010, 1010, we're okay so far. 0011, 0011, 0011, 1001. Yay! You've now just converted a hexadecimal number into 16 binary numbers, or 4 nibbles. How easy was that? Right, so now here's a quick look at Microchip's memory, the application note 1045. So they're saying the year, month, day, hours, minutes, seconds. But we just want the year, month and day. But notice, if I bring up the calculator, the year starts at 1980. But look at this, so 31, go to binary, 31, 30, 29, 28, 27, 26, 25. So we've got 1, 2, 3, 4, 5, 6, 7 ones. Right, so if I choose a different colour, the first 7 bits are the year. So 1, 2, 3, 4, 5, 6. Right, that was it. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right, so that should be the year. So go year, 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 year. So now if we cut this, copy, paste. So our year is everything to the left of this orange line. So we've got 7 digits here, so we have to put a 0 in. Let's bring it up so you don't get confused. Right, so 0. Then we've got, so we've got 7 digits here. 1, 2, 3, 4, 5, 6, 7. Yeah, we've got 8 numbers to fill down here, so put a 0 in here. Then we've got a 0. Then we've got a 1. Then we've got a 0. Then we've got a 1. So am I right so far? 0, 1, 0, 1. 0, 1, 0, 1. Then we've got 0, 0, 1. 0, 0, 1. They've slipped a bit as I saved it, so if I move those over a touch. Right, let's work this out. Windows calculator. Good old Windows. So decimal, we're looking at, these are decimal numbers, the decimal representations of bits in a byte. I explained that months ago. Right, so we've got a 32, no 16s, we've got an 8. So 32 plus 8, no 4s, no 2s, and a 1. So plus 1 equals 41. Right, hang on then. Let's put it here then. That's what it says. 41, and the maths doesn't lie. So our year equals 41. How does that relate to our current year? I created this file just a couple of days ago, put it onto a memory card. Was it yesterday or today? I forget. Remember, I said the year starts at 1980. So, 1980 plus 41 equals 2021, 2021. Let's check that with the calculator. 1980, which is start year, always on a FAT16 file system. So 1980, the year 1980, plus 41 years equals 2021. How difficult was that? You could teach your grandchildren to do this. That was the difficult bit. That's the year, because you need to remember the year starts at 1980. Plus this number, we get 2021. So let's now work out. So we've got a 1 here. That's part of the year, month, and then the date. So let's work out the rest now. Hopefully you're getting the hang of this. Copy, paste. Right, so I mustn't get lost. I'm good at that, losing myself. Hopefully you're enjoying this. Once you know the formula, you'll never forget it. What have we got? 1001. So turning to the data sheet for the month, binary bits 24, 23, 22, 21. So definitely 4 bits for the month. 4 bits for the month, so I've drawn this line in the wrong place. 4 bits for the month. Line 1, 2, 3, 4. There's our month. Right. Put those down here. Change the black. 1001. So that's 1, 0, 0, 1. So we've got an 8 plus a 1, so that's 9. And then the date. Copy this. Paste. Hopefully you're getting the hang of this. I'm doing this live, so concentrating on what I'm saying and what I'm doing, and obviously mistakes and everything. So the date, we've got 5 digits here, 1, 2, 3, 4, 5. So back to black. I think there was a song about that, with that singer. I think she committed suicide. I forget her name. Back to black. Right, so 5 digits. We'll start from the right. 1, 2, 3, 4, 5. No, 7, 6, 5. Start from the left. So we've got a 1 under the 32. 1 under the 16. And it looks like I've gone wrong. 0, 0. Yep. 1. That's why I wanted to start from the right. So if we move all these over, 16, 8, 4, 2 and 1. Right, that would do. I was adding numbers up here that weren't there. So 16 plus 8 is 24, plus 1 equals 25. 25. There we go. So the date that this Paris 1 bitmap was put onto this card, or at least last modified, was the 25th of September 2021. And today is the 27th. There we go, 27th of September 21. So let's use File Explorer and go and have a look. JB card 1, Paris bitmap, date modified, 25th of the 9th, 2021. And the file size is very similar. So if I go back to the C file, and so these very important offset, once you've done a few, it's second nature, sort of, almost. So the file size is 4 bytes, but have a look at my C file, it's all done for you. But so you've got to take, I've shut down the program now, you've got to take the last 4 bytes, remembering their little endian, so 4 bytes, swap the order, and you can work it all out manually as you've just seen me do with the date. So yeah, 25/9/21. It was created at 1421. So going back to that root directory, so we've just worked out the date. That is the time. And these 4 bits here are the size of the file on the disk. So I hope you've enjoyed this trip down memory card lane. Just before I go, I've been talking about the FAT32 SD cards. They're a lot more popular, easier to get hold of, probably cheaper too. So this I'm currently looking at a 16 gig. I think it's SanDisk, whatever. And it's a 16 gig card. There's still the boot sector at sector 0, but you can see it overflows into the second sector. Then there's a bit there. That's the execution code, or for the end of the file there. And there, sector 2. Then we got sector 6. I'm not sure if this is the copy of that boot sector, but the root directory was not within the first 1,000 sectors, and I gave up looking. I'll have to look into how you access the files and the root directory and everything on a FAT32. There are benefits. I mean, A, the cards are more popular. I think you can transfer more than 512 bytes in one hit, but you're still limited to the size of the RAM in your microcontroller. File names aren't limited to 8 bytes. I think they're 32 bits. So yeah, that's for future videos. This video so far is 23 minutes long, excluding the bit I'm saying now. So this video is going to be FAT16 part 2. There will have to be a part 3. You've seen how intimidating all these numbers look to a novice, and it's taken me hours to spell everything out. But then the way I've spelt everything out, hopefully you've now learned how to split up a hexadecimal number into, a couple of nibbles and work everything out without a calculator. Or you can at least check your results with a calculator. Hopefully you found this enjoyable as well as educational. If you've got any comments, leave them down below. If you like the video, don't forget to click like. If you want to make a donation for the hours I've put into this video, feel free. There's a link down below. The C file link is in the first video, not this one. Thanks for watching.